All right, good evening, everybody. I just want to talk for a second about operations with scientific notation real quick. So obviously it is a application of law of exponents. All right, but within that, there may be some issues that come up. For example, let's say you have 6 times 10 to the fourth, all right, times divided by, oh, I'm sorry, not what I wanted. I wanted the other way. Hold on. One flipped. All right. So we could go with 6. 6 times 10 to the fifth will make it. Divided by 8 times 10 to the second. All right, so when we divide, all right, we do 2 divisions. We divide the lead numbers. That's just normal division. 6 divided by 8 would give us 0.75. All right. And then times 10 to the third. Now, our problem is, all right, that's too small. Our number has to be at least 1, but it can't be 10. So it's got to be greater than or equal to 1, but less than 10. All right, so basically what I have to do is I have to make that bigger. If you make this bigger, to compensate, you have to make the exponent smaller. All right, so when I do it, I have to turn 0.75 to 7.5. All right, and I have to make that one smaller for every one I move it over. So my final answer, if it was correct, would be 7.5 times 10 to the second. Okay, and that's going to happen from time to time with division. Now, it works the other way as well. For example, all right, all right, let's say we were using the power law. So 8 times 10 to the negative 4 cubed. All right, so we have to raise both parts to the power of 3, which means we're going to raise 8 to the third. 8 to the third is 512. All right, times 10 to the negative 12. All right, now it's the opposite. My 512 is too big. All right, so basically what I need to do is I need to make that smaller. So the 512 is going to become 5.12. But 2 things. Number 1, I moved it 2 digits. Number 2, I made it smaller. So to compensate for that, now I'm working the opposite. So this needs to be bigger. All right, so that becomes 10 to the negative 10. Remember, when I make a negative number bigger from previous sections, I'm actually, the absolute value part's going to get smaller. All right, so I end up with 5.12 times 10 to the negative 10. All right, so keep that in mind when finalizing your answers. One other tidbit, just so you know, when you're writing 2 things, when you're writing numbers in scientific notation, number 1, if you're writing small numbers, so let's say we got 8.54 times 10 to the negative 9. If you start with a lead 0, and a lead 0 would be a 0 to the left of your decimal point. All right, the number of zeros is the same as the absolute value of my number. All right, so that's going to give me 0.00000, a lot of zeros, 1, 2, 3, 4, 0.854. All right, so you'll notice if we count them 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so the number of zeros is equal to it when it's a negative exponent. Keep in mind, all right, that this is still a positive number. All right, for it to be negative, the lead number needs to be negative. Working the other way, we can't say the same. All right, so if I have 5.756 times 10 to the fifth, all right, I'm not going to have 5 zeros because I have 3 already. So if I move it 3, I'm at the end. And then I just subtract. So I do 5 minus 3, which equals 2. That tells me I have 2 zeros. So I end up with 5756 followed by 2 zeros, 575,600. So with negative exponents, the number of zeros works. However, with positive, it doesn't necessarily work. All right. I hope this helps as you progress this week. Message me with any questions. Stay healthy, everybody, and take care of yourself. All right. Bye bye.